For anyone that's tuning in or joining us, we're going to kick off things shortly in 60 seconds or so. And we should be coming to you live from a few different channels. We're on YouTube, LinkedIn, maybe X, if I got that connected correctly. Very nice. Welcome, we're live. It's 2 p.m. Eastern, 11 a.m. Pacific, and we're excited to have folks join us today. Thank you for joining us live. I'm Anson McCook. I lead customer engineering at Causal, and we'll be hosting today. We're streaming live on YouTube, LinkedIn, and X, so wherever you're watching, drop your questions in the chat, and as we go through the presentation, we will make sure to answer the questions as we get towards the end in the live Q&A session. So ask away during the session or ask away at the end, and we'll be sure to answer those questions. Let me frame up the conversation, and then I'll introduce who I'm joined with today, our other speakers. Paint a picture for you today. Many platform and SRE teams face a challenge today. They're typically running large production environments with small, lean teams. And when issues occur, we get paged, we get alerted all hours of the day, and much of it can be noise. When something then real breaks, triage can take hours because you've got to figure out what's wrong and how far it's spread, what's a symptom, what's a cause. We've all heard AI agents will help with this. We hope they'll help with this. Oftentimes, we're talking about read-only chatbot interactions that are reading back the same information we've got on our dashboards. They're querying raw things like metrics and traces and logs, and they're trying to guess at the best explanation for it, which sometimes can lead to hallucination. And so the purpose of our chat today is to illustrate how you can get to the point where agents are acting on their own and proactively fixing and maintaining production environments. So to show you how this all comes together, how this all works, we've got two guests. First, we've got Cole Murray, creator of OpenInspect, an open source coding agent that does the work. Hello, Cole.
Hey, thanks for having me.
And we've got Martin Roberts, who leads cloud and platform operations at Fountain and runs OpenInspect in production today. Hello, Martin.
Yeah, thanks for having me.
Great to have you guys on. So Cole will kick us off and share more about OpenInspect. I'll spend a few minutes describing how Causal works and the output it provides to trigger an agent. And then Martin will share how it all comes together and how they've implemented it at Fountain. We'll close with any questions you have and where you can try this out yourself. So let's get into it. Cole, I will pass things over to you. Help you share your screen.
Alrighty.
Here it comes.
Alrighty, thanks for having me. So as mentioned, we will kind of run through OpenInspect, what the system does, how it works, the general use cases that teams are working with. Anson will then cover kind of Causal and how it's being applied, and then Martin will finish it out with kind of tying it all together. And then at the very end, we'll take any comments. And so if you have comments, leave them in the chat now, and we will address them at the end. And so to set the context, I'll introduce what are background agents and how they are a bit different, maybe from the typical agents that most people are used to. In most cases, people working with agents, the common way that you are driving this is through your IDE or your terminal. This typically takes the shape of Claude Code, Cursor, Codex, or very other similar tools. And these tools are very interactive. They're designed almost as kind of a co-pilot-like experience where you are interacting back and forth with the agent, and it very much still requires you to be in the loop. Similarly, it requires your laptop to actually be on. And so if it's 3 a.m. in the morning and your laptop is not on, that agent is not able to perform any activity. And so then a background agent is a kind of newer paradigm that has come out where the idea is that we can run this agent in the background on its own infrastructure We can give it its own computer. And with that, we get a few different novel capabilities, such as being able to run the agent on a schedule, being able to trigger the agent, whether through a pull request, an alert, any other kind of source coming into that. And additionally, we can run many of them in parallel because we are not bound to the compute of one specific machine. Specific to a kind of operations use case, what we're discussing today here, it typically follows a very common pattern. We have an event that fires off. We then spin up a sandbox, which contains the developer environment. That environment is also then hooked into our production systems, such as the production database, the production logs, so on. And it will then work on that problem. It's going to look across all of this, gather context, and try to root cause what is actually going on. And then at the very end, it will produce some type of artifact, whether that is taking an action on the system, creating a pull request, or pinging the respective team in Slack. And so with the context of background agents kind of now set, I'll cover into OpenInspect and generally what the system does and how it works at a high level. OpenInspect is an open source background coding agent system. It was modeled after RAMP's internal inspect system. It is fully open source. You can fork it, customize it, kind of make it work exactly to your company's specific services. The infrastructure for this is built primarily on Cloudflare. It uses Cloudflare workers and durable objects for the control plane. For the sandboxes, it uses Modal. It does also support Daytona and Vercel, and there's a few other sandbox providers who will be setting up support shortly. Within the actual sandbox itself, it is using open code. And as mentioned, you can customize this. So if you prefer Pi or some other type of agent coding harness, there is interfaces that you can modify to make that work. And then lastly, we have what we call the clients. The clients are basically just ways that we can access the system. Today, it supports web, Slack, GitHub, Linear, custom webhooks, as well as cron. A question that I commonly get asked is why the project was open source rather than running this as a managed hosted service. I see background agents as a critical infrastructure for companies going forward. And because of that, it's something that you want to own in-house and not have to be concerned about vendor lock-in or being limited in what you can access within the platform. Across the deployments that I've done through my consulting, I see that most teams have to customize the system in some way specific to their company. And I think that that lends itself very well to open source, where otherwise you're kind of working with a company, you're on their backlog and trying to get your features in so that you can support your use cases. The specific architecture of OpenInspect and generally how most background agent systems work is that we have this idea of a control plane. The control plane is basically orchestrating the system. It is what is launching the sandboxes. It's persisting the state of what actually ran within the sandbox, as well as storing things like our secrets and handling callbacks. The data plane that we refer to, this is the sandbox itself. Within the sandbox, we have that agent harness, open code, but we can also put in any of the tools that you have custom built to the project. Very commonly, we see this being custom CLIs, MCPs, for teams with front-end use cases running Agent Browser or Chromium. And this pattern is repeated across many different background agent systems. And so whether it's OpenInspect or many of the other ones available, you'll pretty typically see this split between the control plane and the data plane. For those not familiar with a sandbox, it more or less is just a server. The nomenclature is kind of misleading. It's basically just a ephemeral server. It spins up very fast and most commonly supports things like snapshots, in some cases memory snapshots. And the idea of this is that we want to create a perfectly reproducible copy of the developer environment. Because this copy is perfectly reproducible, we can run many of these simultaneously. They are all completely isolated, and we don't have to worry about any kind of state drift. Whereas if you're working on something on your local host, you might have outstanding files, documents, other things that are kind of subtly influencing the agent. And so now we'll jump into what are the common things that teams are building with this. The first, as we're covering today, is on-call triage and auto-remediation. The system supports both triggers as well as human kicked off triggers. The agent can then root cause through issues, and it can also actually create a fix. And so there's a pretty cool loop here where an alert goes off and a pull request resolving the issue can be created before anyone actually shows up to look at it. The next common use case that we see is customer support. I see a lot of teams using this where the customer support now has access to the agent, and because the agent is hooked into the code base, as well as the documents and the larger company ecosystem, customer support has a much better ability to root cause technical issues. And we see that through the time to resolution for the company's issues, where because they're not waiting for an engineer to jump into the ticket and kind of take over and root cause it, they're able to solve this completely autonomously. I think that this is a pretty huge win for not only the customer support, but also the end customer. Customer support, they end up feeling very empowered by this because they are able to root cause issues end to end. And I think it's a pretty cool experience being able to do that, being able to kind of leverage the AI for technical capabilities. The next common use case we see is PMs. With agents becoming very capable now at writing software, we're seeing the profile of what is known as a builder starting to shift. We're starting to see product managers, designers, even CEOs now jumping back into the code. And historically, there was a pretty big barrier where the team would have to set up a developer environment for that product manager. And it was very difficult for them to maintain that over time because they're not familiar with technologies like Git and Docker. With the background agent system, this is no longer a problem because they don't have to manage that sandbox anymore. It is the perfect copy of the developer environment every time. Other common use cases we see are ops and finance, using this for data analysis, common SQL queries, reporting. With the scheduled cron, I see a lot of teams set up doing weekly reports here, whether that's on their operations, the health of their services, or just kind of customer success type queries where they want to know how is a new feature performing, how is general behavior trending within the app. And lastly, a very common case is prototyping. The OpenInspect, it supports recording and being able to actually view the preview environment. And so teams will iterate on a design, and rather than kind of the team discussing over a document, we can actually discuss it over the prototype that they have running through the system. As mentioned, there's many different ways to interact with the system. It supports Slack, the UI, GitHub, Linear, and the system is built in such a way that it's very easy to extend custom surfaces. And so I see a lot of teams where they've integrated this into their in-house tools, whether that's the CRM, their custom support app, and they're able then to leverage the same system across the company in many of the internal tools. In other cases, I've seen companies actually build products on top of the OpenInspect system, where they're using it to then serve to their end customer, and the customer is then interacting with that same background agent system. There's a couple features that are pretty critical to the teams that they're using. The first is unlimited parallel sessions. When you're running a coding agent locally, you only have so much resources available on your system. In a background agent system, you can create many copies of this in parallel. And so I'll very often see teams who have a large backlog. They will basically just point the agent at the backlog, and it will spin up 50 to 100 sessions simultaneously and basically work through all of them autonomously. A pretty big value add for the system is that it is multiplayer. What that means is that a product manager can be the one who started a session and then a engineer or somebody else can then jump into that same session and bring it over the line. Most coding agent tools don't support that today. Obviously, if it's running on your computer, nobody else is able to jump into that. And so this is a pretty big unlock where teams can now collaborate with the agent. A other common feature that I mentioned is the screenshots in live preview. Teams are able to run applications and record their functionality. This is great for product managers who maybe are not able to review the code, but they are able to look at the recording of the agent interacting with it and then iterate based on that video. And so next, I'll transition over to Anson. As mentioned, agents, they are very good at acting on things, but it's very difficult to actually know what to act on. And refining that process is a task within itself. Before I hand off, a little bit about me. I do offer consulting for the service. And so as teams are deploying this, I would be more than happy to chat with you just on setting it up, any learnings that I've had, and you can find some of my socials here. And with that, I will hand it off.
Awesome. Thank you, Cole. I'm going to add to the stage here. So great context being set there about the context that we feed our agents. So now that we know how the agent works, some of the great common use cases for it, what we now want to focus on is the context it's working from to start the doing. And this is where Causally comes in. Let me build this out a little bit. At the bottom here, you've got your existing telemetry sources, traces, metrics, logs, events, alerts. It doesn't matter if it's proprietary from a vendor or it's open source, Causally works alongside all of this existing telemetry that you've already got. And it takes this data and turns it into causal knowledge. So a live, queryable model of your system. And it takes this raw telemetry, distilling the traces, the metrics, the alerts, the logs, and it creates a semantic layer that organizes all of the entities discovered, all of the relationships they have to each other, and all of the possible symptoms or anomalies that can appear for each of these entities. And there's even more to unpack here, and I'd point you to our documentation as well. But the high level is that with this real-time causal map of your environment, it allows Causally to quickly reason about the anomalies that occur in runtime systems, and then infer the cause and blast radius when issues appear. So it's the causal knowledge that allows an autonomous agent, where does this go? An autonomous agent or engineer to act and fix problems before users even notice. And this knowledge is made accessible in a few different ways. We have a user interface that people can interact with this information. We've got an API, we've got MCP server, or we've got generic webhook. And so when we look at the two different patterns of how people are using Causally, you've got one pattern that is the co-pilot pattern. I think this is the mode most of us know and use with many tools, but an alert fires, some event occurs over here. A human or an agent then queries the Causally MCP server and gets back an answer, a causal inference answer. It says, this is the root cause, this is the blast radius, which is very useful, but it's a very read-only, very reactionary way of interacting with the Causally information. Someone has to ask. Pattern 2, which is maybe the focus of this talk today, especially with what Martin's doing, is autonomous. And this is what this is I think where we're all going. So here in this scenario, no one asks Causally to do anything. Causally has pinpointed an emerging problem, and in this case, we're firing a webhook off to an agent. It triggers the agent to start working with its sources of information, with the context it has from Causally, and submit a PR. And that's the shift we're hoping to see more of. From a read-only assistant you have to prompt to an autonomous engineering loop that acts on its own. And one reason that's important, why that matters, I mean, could you do all of this without causally get from an alert to a PR? Sure, you could, but we recently published a benchmark that documents the results of what happens when you use causely's context with your agent versus without it. And it shows that the context you get helps lower the token usage by 60%. You get a 63% faster diagnosis, a much more trustworthy and accuracy root cause analysis. And this is one that I don't know if everyone sort of documents, but the zero hallucinated incidents. So there's these two benchmarks, or the benchmark we ran was comparing an environment with a known failure versus a totally healthy environment. And the amount of times you ask an agent about a healthy environment, it will start to make up things that aren't necessarily happening there. So by leveraging something like Causely, you get this faster, cheaper, more trustworthy answer back, and it's extremely impactful, necessary, when you're letting an agent start to act on its own to not only open PRs, but potentially merge PRs. So it's the perfect setup for, I think, the main event. Martin, I'll pass things over to you. You can share with us what you built, why you built it, how you did it, and we'd love to see what that is. I'm going to stop sharing my screen. And
Awesome.
I'll share yours.
Great. Yeah, thank you, Anson. Thank you, Cole. I appreciate it. So like they both talked about, OpenInspect and Causely, we found work great together. And I'm going to start with the demo of one of our webhooks that we got from Causely to our OpenInspect platform. This is an example of a session that happened a few days ago, and it was an alert from Causely where Causely noticed that the request success rate went down and alerted our system of this. Like we've been talking about, this is something where previously it would have gone into a Slack channel, and then a human would have picked it up whenever they got a chance, and then would have to open the alert and figure out what's going on, and then open a pull request. I'm going to show you this session here that automatically launched a webhook from Causely, and the open code agent with OpenInspect used the Causely MCP tools along with some other MCP tools that we gave it access to reason about what was wrong, to look at the code, to look at recent code changes. And you can see from the session here, if I keep scrolling down, lots of tool calls, but eventually the agent identified the issue using the report that it got from Causely. It found the root cause, it identified the fix. It gives you all the information you need to figure out what's wrong and what changed. And then it opened a pull request, and it notified our Slack channel that the Causely alerts would have gone to otherwise. So an engineer can take a look at that PR that was posted in the Slack channel, and they can merge it if it looks good, and they can get OpenInspect to review it as well. So this is the first session here. This is an example of something that got fixed this week. So instead of having to go from Causely to Slack to an engineer picking it up, an engineer working on it, finding the issue, and then opening a PR with the fix, that would have probably taken hours, honestly. Instead, we're talking about minutes to resolution. So this is a great example of a Causely alert that we addressed this week. I'm going to show some other sessions too, because we know not everything is going to be an alert. Sometimes the platform breaks and there wasn't an alert for it, right? So another example of an automation in OpenInspect is a cron-based trigger, right? That Cole talked about earlier. So you can also schedule your sessions on a schedule and have it go review your logs, your Causely MCP tools, whatever tools you want. And this is an example of a session here where we told it to go review the logs for OpenInspect, and it did, and found some issues, with our fork of it, and opened a pull request to fix the issue, and this got merged. So another example of how you can use the automations, whether it's a webhook or a cron schedule, to interact with the OpenInspect. We also notice a considerable amount of our usage being in that product kind of space where from Linear, we trigger a session with OpenInspect, if you take this example ticket that I opened yesterday and pretend that our PMs wanted our sign-in page to change to orange, of course, you can take a linear ticket and assign it to the coding agent. This is open inspect. From there, you're going to get a session that's going to have all your agent instructions in it. It's going to tell it what repository to work in, things like that. It's going to go, and like Cole said, one of the most powerful things is the agent can actually take a screenshot itself to verify the work without having to, pull that branch down locally and verify the work yourself. So the agent took a screenshot of their work to verify it was done. OpenInspect also offers like tunnel URL, so you can tunnel into your app and preview it that way as well. So that's one use case. Another extra use case of OpenInspect. One of the great things about OpenInspect is how customizable it is. Like Cole said, a lot of companies he's working with is highly customizing it to meet their needs. We've certainly done that. One example is that linear agent that you just saw, where we take events from linear. We can fully customize the instructions that agents have to code up these changes. We can, of course, do the same thing with the automations. So we can customize the instructions on causal alerts, on your OpenTelemetry backend, your Sentry alerts, all sorts of automations. You can customize the instructions completely to tell the agent how to act. And just one extra example of a way we've customized OpenInspect ourselves is we use a observability platform called LangFuse for tracing our data, and we traced our OpenInspect sessions as well, and we're able to capture data around our tool use in OpenInspect, the open code tool use, so we can capture all sorts of metrics there. These are the kind of things that you would not be able to customize if you pulled a commercial coding agent out there. You just want to get these kind of metrics, right? But we can capture that data and improve our tools and make things faster for our users. These are pretty much the automations that I wanted to show. The last really powerful use case of OpenInspect is in the review portion. So I took the last pull request on the background agents project. If you're looking to get started with OpenInspect, this is the repository for it. In the same way, so this project supports a review bot where on open pull requests you can open a launch a review in your open code session and post comments in the PR with the findings from it. And of course, these can use your tools as needed. So if it needed to go look at something in Causal or telemetry backend or whatever it is, this review agent can make use of those tools that you've set up in OpenInspect. So that is it for the demo today that I have. I know we have some questions already beforehand, and we'd love to hear your questions in the comments. Anson, you want to start?
Yes, for those listening in, please share any questions you've got. I mean, I've got my own, Martin. You were hinting at this early on, but how has this changed the timing responding to things? When an agent starts working relative to the traditional incident flow, and what that's meant for resolving things faster.
Yeah, of course. So an agent works right away. It gets the request. This request comes in and it starts working on it in seconds. Within minutes, it's going to have the root cause identified with help from the causal MCP tools, and it's going to have a pull request opened. That is obviously much, much faster than any other ops team out there can function with just humans working on the problem. It might take someone like me on the ops team a few minutes to even open up the link to the Causal portal and go review the issue and then understand it. And then it's going to take me a few more minutes to go look at all the code changes. Time down from hours to minutes.
Awesome. That's very cool. And maybe in the example of Causal, the webhook that triggers on your side, what instructions does the agent have once it's received one of these causally notifications?
Yeah, you can actually take a look at it here. So nice thing about this is it's all in the open, right? It's available, very transparent. So basically, it receives from Causely a description of what's going on and the JSON from the webhook, and then basically the instructions are like review, review what you just read above, and go use the tools you have available and open a pull request if one's needed, and alert us in Slack if you need to escalate to a human. So the instructions are pretty simple. We tune them over time, make them better as we see sessions that didn't work out as we wanted it to. Yeah.
Perfect. Cool. We've got some audience questions coming in, so I'll pivot to one of those. So from Elizabeth Avenue, how often do you have, let me show this on the screen, how often do you have instances where it loops for a long time to find something trivial? If you do have these sessions, do you have a routine assessment of sessions to inspect bottlenecks?
Yeah, I can answer that. And Cole, you might have some insights from your usage of OpenSpect as well, but it occasionally happens where the agent gets stuck in a loop. We noticed that specifically like this week with RTK, like Rust Token Killer, and Ramp recently wrote a blog post about how they noticed that as well in their inspect agent as well. So we stopped using RTK because the agent expects certain output. And when it sees that the command was modified, it just keeps trying again. So we did see a few loops with that. Nothing too often, a few of those sessions.
Yeah, I think to kind of chime in on that, loops do happen occasionally. I see it especially if you're trying to use the like very cheap models, like if you tried to use Haiku for this, for example, from Anthropic. That model isn't really designed for kind of long-running agent tasks. And so I do find that the intelligence of that model somewhat does matter. That said, you can use skills or custom tools to kind of mitigate this. I think Causely is a perfect example of this, where it's already aggregating all of that context for you ahead of time. And so the agent isn't, kind of endlessly searching through logs trying to find the actual issue.
And we've got another question here that I'll share. Any plans to make OpenInspect work with hosted Git services beyond GitHub?
Yeah, so today it works with GitLab. Someone started working on it for Bitbucket, but I don't think the pull request ended up making it over the line. And the project is open source, and so there is a abstraction in place for different source controls. And so if, I guess this is kind of one of the benefits, right, is that, if you are using something that is outside of that, you can fork it, you can add it, and if so be, you can certainly create a pull request upstream, and happy to review it.
Cool. Got another one here from the audience. How does Causely detect if there's drift during analysis of the alert? Is it adaptive, actively sending procedures to agents to correct, or just spec instructions? Yeah, so as the data comes in live to Causely and we identify symptoms that arise and make a conclusion on root cause, as things continue to change, and if that changes our analysis, each event or each update can trigger additional webhooks to send so that the context is updated. Additionally, any future MCP interaction that an agent is having with Causely is continuing to get the latest real-time current information from the platform as well. And then I've got another question for you, Martin. I think you mentioned a couple of the other solutions, but besides Causely that's getting fed into OpenInspect, what are some of the other tools and setups you have triggering it?
Yeah, triggering it. Yeah, we have a good amount of like just cron triggered schedules, sandboxes, and then we also trigger it from our OpenTelemetry backend. We use a self-hosted solution called Signos there, and we trigger alerts that are very specific to Fountain. We trigger that to OpenInspect, just alerts that maybe Causely wouldn't necessarily have because they're very specific to us. We end up triggering, of course, linear triggers sessions as well when someone has a ticket. And then pull request reviews trigger an open inspect session as well. We launched like 4,000 to 5,000 open inspect sessions per month. So a pretty high volume of sessions.
That's a good number to know. Yeah. And then with the alerts that you're getting from Causally, those aren't necessarily ones you had to tune and figure out and create monitors for. Sort of a little bit different than maybe the other systems where you've created, you know exactly what specific thing happens, then you'd like the agent to take over. But hopefully some time saved there with like not having to think about all of the monitors that need to get created on the Causally side.
Yeah, that's the best part. Yeah, not having to create our own alerts, because we know the 10 things we need to look for, but Causally knows the 1,000 things that it's seen before and has alerts and monitors for.
I think Cole, you had shared like five different patterns, and I think we're gravitating towards that first one where we're fixing things, opening up PRs. Martin, and I don't know if you remember all the ones that Cole displayed, Martin, but are there other places you guys are starting to expand? There was the support example that you had shared, Cole, where support teams are now able to trigger these agents. What's the next big use case you see knocking off the list?
Sure. Our support team actively has tickets in Linear, and they assign that to Open Inspect, and it goes and figures out what code change was related, and sometimes open up pull requests. The biggest thing we're working on right now is improving the experience for our product team, so that they can go from Linear ticket to a pull request with a nice preview, a screenshot with just the changes necessary for the front end. We spent a considerable amount of time just improving that process internally. Yeah,
very cool. Is there more different reliability work you guys plan on taking on now that maybe wouldn't have been so possible before?
Yeah, like every team, there's the more you use agents, the more work that there is to take on, it seems like. Right? So Open Inspect has definitely helped us take on more and more work, because we can just do more things. Like Cole said, you can only run 1 or 2 environments on your laptop, but we could run 5 different problems down, 5 different tickets with Open Inspect. So yeah, we're definitely expanding that. We're looking at past incidents and creating more alerts, more telemetry signals, so that we can detect those quicker. Yeah.
Nice. I probably should have asked this at the beginning. What does the team look like? How big are you guys? I don't know. What are you guys able to tackle now that you weren't tackling before?
Sure. Yeah, we're a relatively small team. We have about 6 or 7 people on my team, and we're able to tackle all sorts of work. We cover cloud work and platform management work, DevOps stuff, and security as well is in our mission. So all sorts of things, and maintaining Open Inspect and connecting it to new things has definitely been a big part of our role too. We're able to tackle all of those different domains because of agents nowadays. So yeah, a pretty big scope for our team.
If someone wants to start building this kind of setup now, what are some of the core pieces of advice you'd give to them when they start their journey?
Sure. Start with identifying the tool that meets your needs. Of course, it has the features you want. We knew we wanted to go from Linear to pull requests. Was kind of the main thing, and Slack as well, and GitHub. So it's really nice when a project like Open Inspect has all that built in. It's easy to get started with that. There's commercial tools out there you can consider. Like I said earlier, they just don't offer the degree of customization. We tried to go down that path and see if we could get our applications running in those kind of providers, and just because they didn't offer the degree of customization, we went back to Open Inspect and made it work for our use case. So definitely figure out what you need, and figure out a project that is actively maintained. Of course, one like Open Inspect that's open source, where you can modify it to your needs is great. Yeah, that's what I'd recommend.
I think
Cool. I don't know
to
if you've-
touch on that is, Martin kind of touched on it, but a big, I think, point when you are working with one of these systems is making sure that you've allocated the human resources to actually improving the use cases.
Yeah.
And so just being the nature of like a autonomous AI system, there is a lot of iteration that goes into this, where you see an issue that the agent, it's maybe not root causing something correctly, or it's not creating your pull requests, it's being overly verbose, so on and so forth. And so there very much is a active part of that system where you are continuing to iterate on it. And I think it's important for teams to be aware of that. I find that maybe people who are less familiar with kind of AI systems starting out, they are maybe like not entirely aware that, hey, this is an ongoing thing. And the joke I make is that once you're on kind of the AI train, there's no getting off of the train. You have to keep working on it continuously, but it pays its dividends, as the more that you're improving it, the better value that you're getting from it. And so whether that's an in-house team or whether that's reaching out to myself, this is a pretty big part of my consulting, where I kind of advise teams through that of, okay, what are the issues that we're seeing? How do we systematically address them so that we're just not kind of playing whack-a-mole with the agent of, please be better.
That's right. It makes the next question I'm going to ask. I think I can anticipate the answer, but either I'll ask Martin maybe first, and then Cole, you can share your perspective if you haven't already. Which is, Martin, like starting to implement this, going from idea to maybe get to where you are now, or to the point where you felt you finally had something working. What was that time frame? Now, Cole, you've just said, I think it always depends, and it's never ending in terms of like just continuous tweaking. But Martin, at least in your case, how long did it take you to get to something that you felt was working?
Yeah, and plus one to everything Cole said. Yeah, you deploy it and then you have to actively maintain it. And we're just now building up our team around maintenance of our fork of the project. But I'd say it takes a few days to just like figure out what you need from a system, what tool works for you. And I think getting started with OpenInspect, if you choose that tool, does not take long at all. Cole has set it up for a few companies, so you'd probably have a better answer there. But now that we've set it up once, I've set it up again a few times for non-prod environments, and it takes about a day to add your Cloudflare and your GitHub and Linear and all those components. I think it's really well documented in the repository as well. But Cole, what have you seen from teams?
Yeah, that pretty closely matches. Typically, teams will have it up and running in a day. Where I see most teams struggling is around the dev environment set up within the sandbox. I find companies are at very different stages of their life cycle and how reproducible that sandbox, that developer environment is. If you're using something like Docker Compose or Ansible or and many other tools, that setup can be very easy. But some teams are kind of running things on bare metal, and they're kind of manually running a bunch of scripts. And so I do find that can create a bit of friction. Once you get past the developer environment, though, I find that it's very smooth sailing, where teams are able to quickly then start wiring it into their different systems. That sometimes does take a bit of iteration as well, where maybe their internal systems don't have the best access control because they're previously just relying on good human judgment. And so sometimes there's some work there to address the security related aspects. But other than that, I think it's fairly easy to get set up, and then the sky is kind of the limit on how far you want to push it.
Yeah. We've got another audience question. So 4,000 OpenInspect sessions a month is a lot. How much time is spent in reviews by devs? Is in this case, do you have some sort of automated system where certain low impact fixes are merged automatically? Maybe that's for Martin. Yeah.
Sure. Yeah, I'll take that first. Yeah. So roughly like 30% of our sessions are just pull request reviews because that runs an OpenInspect system as well. So of course, they're not adding any new pull requests. They're actually helping reduce the burden on our devs by adding feedback in pull requests. And OpenInspect does offer a way to, or OpenInspect by default, I'm sorry, can support merging or approving low-risk PRs. We've customized that functionality a little bit for our use case, but the other 70% of our sessions, they're not all opening pull requests. We have things that do a review, things like reviewing our test suite to see if there's flaky tests that we need to disable. Those kind of things don't always open a pull request. If we say get an alert from Causally webhook, we have the agent look and see if there's already a pull request that fixes this. Sometimes there is, so a pull request doesn't get opened for that. But yeah, a significant part of our engineers' time is being spent reviewing some of these things. We could ship faster if we shift towards having engineers do some of the review instead of doing the coding by hand.
Yeah, and that kind of matches what I see as well across teams where, as mentioned, OpenInspect can automatically approve the pull requests, and you can build any kind of custom tooling around that. I see a lot of teams adding in custom rules where, if the pull request is under, let's say, 300 lines change, and it doesn't touch auth py or various other files, we're just going to autonomously merge that in. I think that that's kind of one of the beauties of being able to own the system, is that level of discretion is kind of up to you as a company, and you can really customize it and make it deterministic if you want, right? You could add in custom tools and have that agent running n many checks. Maybe some of those are compliance checks, and if it passes through all of them, it can then merge it. Across some of the deployments, the highest number that I've seen is 25% of their pull requests are autonomously merged. They put in a lot of effort to do that refining to get it to that point. Kind of as we were mentioning, just iterating, making sure that the agent is very concise in its changes. But I think that that's a pretty good kind of North Star number where it gives a good trajectory that you can work towards.
We've got another question here from the audience. How does Causally determine root cause, not just correlation? I'll take that one. So out of the box, Causally ships with these causal models that are built off of domain knowledge that we've built over the years. They effectively are these definitions of how things typically fail in microservice architectures, how async communication can fail, databases can fail, and how these tend to propagate throughout other systems that are connected to them. All of this out-of-the-box knowledge, these causal models, are then automatically married to your telemetry, your data, your services, and with that is how Causally is now able to confidently say, well, these aren't just two random events that are happening at the same time. We know that when A happens, B can be an explanation for why that happens, a cause for why that happens. We know the inverse as well. These are all the possible symptoms that can be explained by these root causes. These are the root causes that can cause these symptoms. And it's these causal maps that have been created under the covers for you. And when certain types of symptoms appear, with some probability, Causally can do this causal inference to say, this is the cause that best explains why these symptoms are present. And there's very cool, innovative ways in which you can influence the analysis that Causally is doing, whether that's by thresholding, whether that's by SLAs, whether that's defining your own root causes based on specific types of alerts that you have. So you can also build off of the models that Causally is shipping with out of the box. This maybe is another question back to maybe Cole. We've got our Martin, our multi-repo sessions on the roadmap in the short term?
Yeah, I get this question a lot, and currently no. And my hot take is that in general, you probably don't want actual multi-repo sessions. And the reason for that is that if you were making a change in both your front end and the back end at the same time, and the agent is working on them together, it very likely is going to make a change that is not backwards compatible. And so as those pull requests then get merged in, they're both going to deploy at the same time. And you will then have an outage because the backend changes have not landed yet and the front end changes have, or vice versa. And so kind of just as like a whole, I'm not totally sold on the idea of like multi-repo sessions. That said, you can use the custom hooks within OpenInspect to clone down those different repositories. And so I see a lot of teams do that where they want the code local, but they don't want to actually create pull requests against it. They just kind of want to be able to look at it to better root cause their issues. And so that is supported out of the box. You can easily wire that up. And if you want multi-repo sessions, you can certainly fork and add them in. And my perspective on it might change over time. Maybe we'll add it in. But yeah.
Cool. Got another Causely question. Does Causely come up with a single confident root cause versus multiple candidates? What you're presented in the interface is the root cause, one root cause that explains the symptoms that are happening now. It's also worth mentioning that as the environment changes and either new symptoms appear or some symptoms disappear, Causely will update the single root cause that best explains those symptoms. So there's opportunities where maybe a good example is when symptoms start to pop up, Causely can generally say, oh, this service is suffering, and this is slow, and it's causing degradation everywhere else. But as more symptoms come in, if you think of this as like a bullseye, that sort of explanation of like generic slowness is kind of on the outside of that bullseye. As more symptoms come in that help us tighten the specific cause of that slowness, it's this database query here that's running that's causing the slowness, then the root cause updates itself. But you're not given multiple root causes to explain a symptom or alert that's happening. You are always presented one at a time for all of those symptoms. Any other questions from the audience? Got a little bit of time left. If not, thank you, Cole. Thank you, Martin. And yes, many thanks, Martin, for walking us through how it all works in real life, and Cole for showing us how OpenInspect makes it all work, and for all of you joining us live. Before we go, let me share my screen one more time. If any of this resonated with you, you don't have to take our word for it. You can try it all yourself. So at least on the Causely side, you can go to causely.ai/agent, and you can deploy Causely for yourself, connect it to your own agent over MCP, and watch it work on your environment. And that's the fastest way to see the causal context turn itself into action. And if you're building AI systems and want a hand, Cole does fractional CTO work and AI consulting for seed and Series A teams building AI products. So you can reach out to him via his website, murraycole.com/services. And we've been talking a lot about OpenInspect. We've got the link there as well on GitHub. You can start to deploy that and get your hands dirty getting this up and running. And as Martin and Cole both attested to, it can be a pretty quick process getting this up and running that we know will pays large dividends once you get it all working. So go try Causely, check out Cole, and if you're in the market for AI native workforce automation, check out Fountain. We know that there's some top-notch engineers running things under the covers for Fountain there. So perfect. Thank you for spending the hour with us, and we'll see you all next time.
Thanks, guys.